Okay, so 5.1, let's do a couple examples and then we'll move on to 5.2. The first thing I want you to be able to do is convert from degrees to radians and determine what quadrant that angle is in. That's the first basic thing. So on this one, let's go ahead and convert to degrees. Let's multiply by, I don't know, 180 over pi, which is your conversion factor. This will cancel your pi, getting you to a negative 180 over 3, which is negative 60, right? So this is all equal. Now convert this. Oh, now find your coterminal angle because it's negative, right? So adjust by adding 360. So if it is negative, you have to add 360. All right, a little note here. Find the coterminal angle. That gives me 300, right? Okay. So there is my converted angle, the coterminal angle. Now we can figure out what quadrant are we in. Quadrant 4. Yeah, it's gonna be quadrant 4, right? So 300 degrees is in quadrant 4. Okay. Any questions on those ideas? Can you find any coterminal angle? And can you find what quadrant we're in? Do you see why it is 4? Okay. Let's go ahead and do D. I'll leave the rest to you. 714 is greater than 360, right? So let's just subtract until we're below 360. So 714, I can't see the calculator there. Okay. My other calculator died. So minus 360. Once you hit below 360, that's the angle we're going to use. So coterminal angle is 354. What quadrant is that in? Still 4, right? Okay, so we'll convert it first and then write down the quadrant because it did say to convert. So we're in degrees, change to radians. So I'm going to use the coterminal, multiply by pi over 180. So whatever you want to cancel goes on the bottom. If I want to get rid of degrees, I have degrees down, right? I don't know how nicely this will reduce, but here we go. All right, does 4 go into 354? No. 2. Didn't have degrees anymore at this point. They cancel here. All right, so we have 177 pi over 90. That's all in radians. Does that reduce any further? I can't tell by looking at it, but we can try dividing by factors of 90 into 177. That's the easiest way to do this. 9 and 10 go into 90, right? So does 3. So does 2, but 2 is not going to work because that's obvious. Maybe 3, yeah. Let's see. Yeah, 3 is a good one. About 9 though. Oops. Nope. So if we use 3, we will get 59 pi over 90 divided by 3. What's that going to be? I think that's as good as it's going to get, right? This is your converted form, reduced. And quadrant, we said 4, right? Anyway, I'll leave B and C to you. These ideas make sense. Yeah. Yeah, we can do C. No big deal. Do you have another question?
I was gonna ask for the angles that are over 360, we're gonna have to get a quaternion angle and then on that based on the quadrant that angle.
Yeah, it'll be the same. Either the big one or the coterminal will be the same spot. So, but it's easier to see if you find a coterminal because I can find 300 from the circle. If it's like, I don't know, 1,000 something, it might be harder to see. So just adjust it. Okay, this is 5 radians. So there is no degree symbol. Assume radians. So multiply by pi over 180. Oops, that's backwards. I want to cancel the pi, but there is no pi. Invisible pi. So that'll give me 5 times 180 over pi. I don't think this is going to be, I don't think it's going to get very exact. Where's the pi button? This guy. Hmm. So this doesn't get very exact. The best it's going to get for this particular example is 286.48 degrees. What quadrant is that?
4.
Is it 4?
Yeah, 4.
Yeah, so 270 is right here. 286 is about there. Yeah. Quadrant 4. Okay. Let's move on. Go ahead and go over coterminal a little bit more. Yeah, we'll do the next page. You guys cool on this page? All right. So let me know if I go too fast at any point, or if I make no sense. Find the coterminal angles between 0 and 360. A, B, C. D. Okay. So 625 degrees, 1034 degrees, 698. A weird 8. 29 pi. A weird pi. Okay. All right, let's do I don't know. Let's do B, I guess, first. To find the coterminal angle between 0 and 360. So if it's bigger than 360, just keep subtracting full circles. Right, so you can do that on your calculator real quick if you want to. 1034 minus 360 minus 360. As soon as you're below 360, you're good. That's the angle you want. Okay, so minus 360 minus 360. Is that straightforward? All right, let's do that weirdo one here. 29 pi over 10. So you can either change the degrees and then work on it, or just add 2 pi. That's the same as 360. So since this is negative, you gotta get out of the negatives, add 2 pi, right? If you were to convert it, you would add 360. It's the same thing. Although this is a fraction, so you have to deal with fractions, you agree that this is the same as 20 pi over 10. You multiply the top and bottom by 10, you get the same denominator. You find the LCD. So at that point, you just add them together. Negative 29 plus 20, that is a negative 9, right? Add another 2 pi. That'll get me to 11 pi. Does that make sense? Just like before, we had 360, 360 here, or here we subtracted because it was too big. If it was negative, you would add, like part C, you just keep adding until you're positive, and then you stop. If it's radians, you're going to do this. Just deal with your fractions. Any questions on part D? That okay? Yeah.
Convert to degrees of.
It depends what they ask for. If it's in radians, just keep it in radians. But if you want to convert, that's not a big deal. It's fine. Yes. Is there a question or good? Like we could alternate version. We could convert it right away. Let's say you hate radians or you don't want to deal with the fraction. You could convert it, right? These pi's are going to cancel. Let's go ahead and show everything. Pi's are gone. 10 goes into 180 18 times. So I'm left with negative 29 times 18. Okay. Once you get there, just keep adding 360 like we did here with a 2 pi and you'll be good. So just an alternate way. So plus 360 until we're done. So that is negative 522 plus 360 plus 360. We're going to get 198. So this is the same as 11 pi. Negative 162, 198. So these are the same. Anyway, any questions on finding coterminals? Technically, all these are coterminal, right? But they specifically wanted one between 0 and 360, so make sure you use one of those. Okay. There's an infinite number of them, so they have to restrict. You guys cool on number 2 here? All right, let's move on to 5.2 then, I guess. 5.1, the main thing you need to worry about is, can you convert from degrees to radians, radians to degrees, and you find coterminal angles. That's pretty much it. Five point two. Then you start using the unit circle, and you do mainly with sine and cosine. So the first thing I want you to do is find the exact value of the following. Sine of 7 pi over 3 and cosine of 7 pi over 3. The 7 pi over 3, that's technically too big. So use the coterminal angle. So subtract 2 pi, because it's more than 360. Get a common denominator. This would be 6 pi over 3, which is pi thirds, right? So this is the same as sine pi over 3. This is the same as cosine of pi over 3. All right, well, what is that? It's right here, right? Sine is the y value. And what is cosine going to be? Yeah, that's it. So far, not too bad, right? It's my scratch work here. So if the angle is too big or negative, just adjust and then find it on the circle. That's all you got to do. So let's do one more of those. This time, let's say the angle is really huge. Right? 1290 is too big. So subtract 360, subtract 360, subtract 360. As soon as you're below 360, use that angle instead. That's going to be on your circle. So I'm going to get 210, 210. What is the x and y value for sine for 210 degrees? What did you get for sine? 1/2? Yeah. That's quadrant 3, so they're both negative. Yes.
So we're gonna get to use the unit circle on the, that's,
Yeah, that'll be a separate formula page.
okay.
So you can have that just there, and then one page of formulas front and back, but just formulas, no examples. You'll turn in both sheets with your test. Although if you need a formula, just ask me and I'll put it on the board. It's not a big deal. Okay. If you forget something, it's not about memorization. Okay. You guys cool on 1 and 2? You see the main idea? So we're just finding the coterminal angle and then identifying it on the circle. So number 3 is when they start talking about reference angle. So I think that's the last thing on 5.2 that we should worry about. Reference angles, whatever. Excuse me. So there is a rule for each quadrant, right? Remember the homework or the notes? Depending on which quadrant you're in, you'll follow a different rule. So the first thing you gotta do is figure out where the heck is that angle in? Which quadrant is it in? Okay. So 195 is 3, right? You can always check if you're unsure. 180 is right there, 195 is somewhere in here. Somewhere in there. Okay, so it's right before, right after 180, quadrant 3. The rule for quadrant 3 says you take the angle in question and subtract 180. That is for the rule of quadrant 3. So this is my reference angle. Okay. Any questions on part A? This is just the rule. So you should have the, yes, quadrant 3, quad. Part B, 298, where is this? The rule for 4 is, let's see here. Yeah. Subtract from 360. So you take the angle in question and subtract it from 360. 360 minus 298. 62, right? So that is the rule for quadrant 4. I believe towards the end of 5.2 they have the set of rules, if you don't have them in the book. C. This one's negative, so adjust first and then figure out where you are on the circle. So 360. Where is 148? 2. What is the rule for quadrant 2? Do you remember? Yeah, it's going to be 180 minus 148, which gives us 30. Yeah, 32. So far, you guys okay? All right. D is 431. Obviously, that's too big, right? So 431 minus 360. going to be 71. Where is 71? And what's the rule for quadrant 1? Yeah, there's nothing else to do. This is the answer. So that's the easiest quadrant, right? It's the one we want. Whatever answer you get, that's what it is. So if it's 45, it's 45. The reference is equal to the angle. Okay, so that's 5-2. So the main ideas, I guess, I want you to focus on is find sine and cosine of the different types of angles. Adjust if you need to, find the coterminals, and then you do sine and cosine either in degrees or radians, and then find reference angles. As long as you can do those things, you should be good for 5.2. Okay. Any questions on 5.2? Put up 5.3. You guys okay on this page? Let me know. 5.3, the other trig functions. So basically similar to what we just did, except you do all 6. Find the exact value of the following. So negative 5 pi over 6. So they're all going to be the same angle, negative 5 pi over 6. Okay, and then cotan. So the first thing I want you to do is adjust, because then that angle is negative, right? If it's negative, just add 2 pi. We'll do that over here. If you add 2 pi, that'll be the same as multiplying by 6 over 6. Negative 5 plus 12. My scratch work over here. So that's the same as finding sine of 7 pi 6. So that should be on the circle. So I'm just going to go and change it to the coterminal angle. And then we'll solve it. Okay.
So I like to do like 5 pi over 6 is only it's like negative. So I kind of just like to see what the circle or not on the opposite.
Yeah, you can. It's the same thing. So you just try to figure out where it is. Yeah, that's no big deal. Because if you go negative 5/6, that's basically 150, right? So you could go.
I just kind of like, that's probably where
Yeah, so it'd be like over here, right?
Yeah.
Which is the same thing. Yeah. All right, so sine. What is sine of 7/6? Negative half. Cosine of 7/6. It's negative, right? Okay. Now, tangent is the ratio of sine over cosine. So divide these two. Negative divided by negative is going to give you positive 1 over root 3. 3, not 2. Because if you divide by it, you're going to have this. Negative half divided by square root 3 over 2. 2's cancel. You get 1 over root 3. Right? Yeah, you can. Either way is fine. I'm not going to require one or the other. I think the homework accepted this too, right? So it's fine. Cosecant is a reciprocal of sine, so it's just -2. Flip over the half. Secant is this flipped over. Cosine. Tangent flipped over would be this. Any questions on first one, 5.3? That clear?
For the exam,
Mhm.
is 1 over square root of 3 the same as square root of 8?
Yes. Yeah, if you rationalize, if you want one more step, you would get this. Yeah, I'll take either one. I mean, you should know how to rationalize, but it's not required. All right. So number 2, find the 6 trig functions. Oh, yes.
That, I like the word example where it's u plus. Cosine, is that gonna be understood?
No.
No.
But you should have your formulas that we talked about. You should have them ready. Okay. Cosine theta is equal to 5 over 13. And let's see here. Theta is between 3 pi over 2 and 2 pi. Which quadrant would that be? Yeah, this is the 4th quadrant, right? So between here and here, that's quadrant 4. You could use triangles to solve this, but in this section they use the formula, right? So solve for sine. You do it in general and then just plug it in. So if I subtract cosine right now, I would have 1 minus cosine, right? Square root both sides, and you're going to have plus or minus this garbage here. So sine theta is equal to, now is sine negative here? Quadrant 4. So we should use the minus. Okay. Go ahead and plug it in. That'd be negative square root 1 minus 5/13 squared. If you want to use your calculator, you can here. 1 minus 5/13 squared. (144 over 169). If you would just show your work, it would just be simply 169 over 169 minus 25 over 169, which will get you to 144 over 169, which is negative 12/13. That's sine. I did the inside right here. That's where this comes from. So just do your fraction, square this, and then do your common denominator. I skipped the common denominator here. 1 is equal to 169 over 169. Anyway, so we have sine theta equal to negative 12/13. Cosine theta equal to 5/13. What is tangent theta? Yeah, you would divide these, you would get negative 12 over 5. Once you find the first three, the rest would be easy. Is there any questions on the arithmetic?
What is it instead of like sine 13? It gives us
You would, for these questions, I don't think it gave us any other formulas, right? If that happened, then you should use triangles from the next chapter. I think that would be more of a chapter 6 problem. Find the other 6, or the other 3. Cosecant, secant, cotangent, any questions on any of these steps here? Is it okay?
Maybe one time.
Yeah. I'll give you at least one. Not more than 2 though, 2 or less. I mean, if I haven't made it yet, but this is, consider this my rough draft for your exam as we're going. I'm gonna pick problems out of here, change them a bit, and maybe pick a couple from your examples or homework. I'd say majority would be from what we're doing right now. Okay. So that's pretty much it for 5.3. The main thing I want you to be, main things would be find angles either on the circle or if they're not on the circle, you find the coterminal and then give me sine, cosine, tangent, secant, etc. If I give you one of them and some information, find the rest. Okay, so if I give you like a hint and one of the trig functions, you should be able to find the rest, just like we did here. Okay. You guys cool on 5.3? Okay. I think we'll save. Well, let's just do one more. Okay. Find the exact values. So if I give you, let me give you the triangle right here and tell you to find all 6 trig functions. Here's theta. Here's lowercase phi. Y is 6. X is 8. Z is 10. So part A, find sine theta. Part B, find cosine theta. C, find tangent of theta. D, find sine of phi. E, find cosine of phi. Then tangent phi. What is sine of theta? 6/10, which reduces 3/5. What is cosine of theta? Eight over 10, which reduces. Yeah. Tangent of theta. Yeah, the opposite over the so over 8. Okay. Sine of phi. So now we're up here. Opposite hypotenuse. Cosine phi. Yeah. Tangent phi. It's opposite would be 8/6, 4/3. Okay. Any questions on number 1 here?
The values always have to be real.
Yeah, we should.
All right, we'll stop here for today. Do you have any homework questions you're struggling with? We'll continue Friday on the review.